Okay, multiplying and dividing whole numbers in practical applications. I'm going to teach this a little differently, okay? Example 1 says I can type 12 pages per hour. How many pages can I type in 6 hours? So I want to know pages. How many pages? That's the answer to the problem. Okay, so here's what I want you to do. I don't want you to do this. This is how I'm going to do it. I mean, I don't not want you, but this is how I'm going to set up some of these problems. If you think that that I'm overcomplicating it, then just do it a quick way. It's fine, okay? I'm not going to be offended. But some of them do get a little sketchy. They're, like this is an easy problem. Everybody knows you can just take 12 times 6, okay? But there are some that get a little dicey, okay? If you get in a pinch, you might want to use the method I'm using to set them up, okay? I'm going to actually use proportions here. So go find pages in the problem. You said 12 pages, but it's per hour. Per means 1, okay? So there's your ratio, 12 pages, 1 hour. That's your rate. This is the actual amount that you have. Well, line up the labels same way, and we need to find the pages, and there are actually 6 hours. So 12 times 6 is 72 divided by 172. Okay, example 2. 2,000 feet of electrical cords are manufactured each day. Okay. How many feet are manufactured each week? The plant is closed on Saturdays and Sundays, so you want to know feet. So again, I'm going to put rate, actual, or R and A works, and I'm going to set up proportions. Now find feet. It says 2,000 feet, but you need to keep reading. I mean, that's part of your ratio of the rate, but it says each day. Each and per mean the same thing, boys and girls, ladies and gentlemen, okay? So each means 1 as well. So like per, each is 1 day. That's the rate. Feet, days. Well, we're finding the actual feet. How many days we have? Well, it's for the whole week, and the week has 7 days, but it's closed on Saturdays and Sundays, so that would be 5. So I would multiply 2,000 times 5 divided by 1, and that gives me 10,000. Okay, example 3. A welder manufactures 35 steel structures for a price of $7,850. Find the cost of each structure. So you're finding the cost, but you're not finding the actual cost. You're finding the cost for each structure. So you're not just here. If it's cost, put a dollar sign. But you need to add a little something to that. You're finding the cost of each structure. So it's your job to find the cost of one structure on this problem. Okay. Now, if your job is to find the cost, then the rate is what you're finding. So the question mark is going to be over here this time. So I'm going to put money and structures. I know one structure is the rate, but I don't know the cost. Okay, so money, structures. Now what's the actual amount? Well, the actual amount was 7,850 to 35. So I cross multiply and divide. Well, it ends up just being this divided by 35. 7,850 divided by 35. Okay, $224.29. Okay, example 4. Truck travels 2,500 miles on 200 gallons of fuel. How many miles per gallon does a truck average? So you're not only just finding the miles, you're finding the miles per gallon. So I'm going to put miles, and then per gallon means you're finding the miles for 1 gallon. So you are finding the rate, okay? So the question mark's over here. Rate actual. So MG. So the rate is 1 gallon, but I don't know how many miles. Now the actual, I have the actual, 2,500 miles, 200 gallons. So it ends up being that times 1 is 2,500 divided by 20 is 12.5. So when you are finding the rate, okay, the question's over here. When you're not finding the rate, like on these two, the question's over here. Okay, it's kind of simple as I can put it. Okay, example 5. You need to find the length of dimension A. Okay, so look at the parallel dimension. It's 200 feet, the outside parallel. Now it's like this is like a plate, and these are bolts, these little circles. So I need to find how far it is between each bolt up here for part A. There's 2 rows of bolts, the little bolts and the big bolts. First I'm finding how the distance between each big bolt. Okay, well first I need to do is subtract the outsides, 20 and 10. 20 and 10. Well, that's 170. So from the first bolt to the center bolt. Now you don't want to be overly technical. I know there's this little space. No, there's not. Okay, never mind. Forget about what I just said. So 170. Now you're obviously going to have to divide that space because all of these spaces are equal. So you're dividing it. Now here's my advice to you. Count the bolts. 1, 2, 3, 4, 5, 6, 7. Don't divide by 7 though, because there's not 7 spaces between the bolts. There's 1, 2, 3, 4, 5, 6. There is always one less space than bolts. So I take 170 divided by 6. All right, I don't want that. When we're measuring with feet and inches, when you get something like this, I want you to go second, PRB equals, and it's 28 1/3, which a lot of you know because 0.3 repeating is 1/3, 28 1/3 of a foot. Be 28 feet 4 inches. You don't need to write 4 inches, but that's what 1/3 of a foot is. It's 4 out of 12. Okay, dimension B. We have 200 on the outside, and now I subtract 40 and I subtract 10 because those are the outsides that I need to just get rid of. And then I divide. Now count the bolts. 1, 2, 3, 4, 5, 6, 7, 8, 9. But we don't divide by 9. We divide by 8 because there are 8 spaces. So 150 divided by 8 is 18.75. Now I go second, PRB equals, and I get 18 3/4 of a foot, which is 9 inches, by the way, because 3/4 out of 12 is 9. Because I'm saying 12 because 12 inches in a foot. Okay, example 6. In any commercial plant, machines produce 1,000 dozen rolls of electrical cable in 10 hours. How many single rows are produced per minute? So put rolls per, actually instead of per minute, remember per means 1. You want to find the rolls you're able to produce in 1 minute. Okay, so you are finding the rate actual. The question is over here. Okay, so rolls minutes, don't get ahead of yourself either. Okay, so we're going to find 1 minute and question mark for the rolls. Now the actual amount, we got 1,000 dozen. This means you need to take 1,000 times 12 because dozen is 12. So that's 12,000. Now the minutes, well it says 10 hours. Well, to convert the hours to minutes, you just take 10 times 60 because there's 60 minutes in an hour. 600. So this times this, so really it's just 12,000 divided by 600, and that is going to be 20 rolls in 1 minute. Okay, now the next is an easy problem. It's just very annoying. Okay. I'm not really going to over-explain it too much. It says this: a landscaper determines the weight of his steel beams required for a proposed job. The table lists the data used in finding the total weight. So he's building something out of steel beams. Okay, find the total weight of all the beams. So he's got these 17-inch by 8-inch beams. The dimensions of that, the 17 and the 8, don't matter because we're finding the weight. Well, they weigh 50 pounds per foot. Well, how many feet you got? Well, you got 8 feet, so I'm going to take 50 times 8. Okay, that's how much one of those beams weighs. One of the 17 by 8-inch beams, that's how much they weigh. But we need 12 of them, so then I times by 12. 4,800. Okay, then the number of 8-foot lengths still on that, okay? 20 inches by 7 inches, those weigh 45 pounds per foot. Well, it's 8 feet, but that's just one of the beams. Now we times by 16, 5,760. Now I'm not going to go through this whole table. This one you take 35 times 8 times 19. Now you take 50 times 12 times 8, 4,800, and then 45 times 12 times 25, 13,500, 5,880. Now I'm gonna move on along because this is gonna take forever. If I actually figured this out before I went on video, and then we add them all up. That's 125,200. Okay. You have to add them all together because the total weight is all the beams together. You load them up in a big truck. That's the weight, although in feet's not the correct label, it would be pounds. I'm an idiot. Okay, next one. An electrical contractor has 150 houses to install a cable box. Each workday cable can be installed in 10 houses. How many work days are required to install the cable in all the boxes? So we're just finding work days. It doesn't say per or each. I'm just finding the work days. So rate actual, question mark's going to be over here. Okay, give me work days. Okay. What says each work day? Remember, each means one. So I put one work day with 10 houses. That's your rate. So workday, houses, workday, houses. We know the rate because we know we're not finding the rate, so we must be able to fill out the rate. Okay, so one workday is 10 houses. We have 150 houses, so yeah, it ends up being 150 divided by 10, which is 15. You see me make a lot of work out of ratios in this class. Okay? Most common street math concept you would use. If you don't know like what else, if you don't know how to figure it out just operationally, that's where we go. Example 9, a contractor estimated that 25, by the way, this problem is wrong. I've written the wrong thing. You need to cross out 30,000 and put 900,000. Contractor estimated that 25,000 square feet of sheet metal would be sold each day during August. August has 24 business days. That means it's closed on 7 days that we don't worry about. During August, 900,000 square feet were actually sold. How many more square feet of sheet metal will actually be sold than estimated each month? So here's what you do. You need to set up two categories because it says how many more. Well, how many more were actually sold? So it's sold minus estimated. And we are finding square feet. Okay, I know one of these. I know we sold 900,000. Not sure how many I estimated, okay? So 25,000 square feet of sheet metal would be sold each. Remember, each means one, so we know our ratio. One is going to be square feet, and it doesn't matter the order this is set up. You can put the square feet on top or the days on top, doesn't matter. 1 day. So 1 day is 25,000 square feet. We know our ratio. And we are trying to figure out the square feet, okay? We do know the actual number of days, okay? The actual number of days was 24. So 25,000 times 24, 600,000, okay? And then you just subtract them, it's 300,000. Okay, example 10, a manufacturer decides that 25 fluid ounces of Roundup are needed for each, there's that word, one bottle of Roundup. If you have each or per with a noun after it, a thing after it, it means one of those. Can't emphasize that enough, of Roundup. The plant has 200 quarts of Roundup. How many bottles can be produced? Okay, so we want to know bottles. Okay, now I'm not finding the rate, I'm finding the actual. Okay, rate actual. Okay, so obviously we have bottles, and we have one bottle, that's the rate quantity. We have 25 fluid ounces, so FLOZ 25. Then the labels, don't get flustered, stick to the plan. Because remember, we said the question mark was over here with the actual bottles. Now there's a little problem, okay? You got 200 quarts. We need to convert the quarts into fluid ounces, and that's what we use this for. So you're going to make a mini proportion up there, and you're going to put 1 quart, 32 ounces. Line those labels up. You want to convert those 200 quarts into ounces. So 32 times 200 divided by 1, and that's 6,400. So that's how many ounces we actually have. Now we can cross multiply and divide. It ends up being 6,400 divided by 25. 256 bottles. Okay. See, on a problem like that, you definitely might want to set up the rate actual. Okay. Okay, example 11. I think these are dumb when they do the rounding and then the actual. Do the actual first. An electromagnet is wound with 76 layers. Each layer, remember there's that word, one layer, requires 128 turns. Find the number of turns on each magnet. Okay, rate actual. All right, so turns has to be a unit. So what do we have for turn? 128 turns, one layer. So turns and layer. So the rate is known. What we don't know is the actual number of turns. And it doesn't matter, again, what goes on top turns or layers, because if you line, but you do have to line them up so they match. Okay. All right, so we have 76 layers, and we cross multiply and divide. 128. So it's really just 128 times 76. 9,728. Now what did I just do? I really just multiplied them. Now it says round each number the nearest 10 and find the number of turns. Well, now nearest 10, that would be the 2, that'd be 130. And that would be the 7, so that would be 130 times 80. You just round those numbers. So it's 130 times 80. 10,400. So the estimated amount is more than the actual amount. That's fine. So do the actual problem first, and then you can come back and mess around and do the estimated. Okay, example 12. An iron fabricator finds the material requirements for the railing drawn. Okay. How many vertical 1-inch square wrought iron, that's these little posts, these beam kind of things in here, are needed for this job? So again, we have the 240 inches outside. The 20 feet we're not going to use, because all this inches, so I'd want to use the inches. Well, again, we subtract these outsides, okay? 12 and 12, okay? Hold on a second, I made a little mistake, I'm sorry, okay? It should say from here to here's 12, okay, I forgot to give you what it is from here to here. That's my bad. Okay. We're going to make up something 5 inches and 5 inches. Okay. So we have to subtract 5, 5, 12, and 12 because the 18s are right here. Okay. Okay. So we minus 12, minus 12, minus 5, minus 5. So you subtract the outsides. That gives you 206. So it's 206 feet. Okay. Now, hold on, let me read. I'm sorry, I'm bumbling my way through this problem. Okay, I apologize. Get rid of the 5s. Okay, apologize for that. I apologize. Okay, take your 240 just like before. subtract 12 and 12, forget about the 5s. Okay. Just forget that's even there. Okay, I should have just said get rid of those. 240 minus 12 is 216. Now you want to divide by how far a space is. You want to divide by 18. Okay. So I got 12, but 12 isn't the answer, and here's why. There are 12 spaces. Okay, when you divide, that's the number of spaces. Remember, there's always one more post than there are spaces. One more post than spaces, so you add one, and it's 13 of the square root. Okay. Well, at least I think that's how I say that word. Some of you probably know that better than I do. So 240 minus 12, then divide by 18, because every space is 18, okay? And that's how many spaces, but remember, there's always one more post than there are spaces, so don't forget that. Okay, example 13. To complete a job, a contractor determines that 500 hours are needed. 4 workers work 5 days per week and 8 hours per day. How many weeks will it take for the job? Okay, so 4 workers work 5 days. Remember, per means 1, and per means 1. Now, we're concerned about the weeks, so we want to use, in the rate actual, we want to use the one with the weeks, the 5 days for 1 week. Okay, so 5 days, 1 week. So days, weeks. We're finding the number of days. Now, do I know the actual number of days? Well, you're going to figure it out. You know it's going to take 500 hours. Now, how do you convert hours to days? Normally you divide by 24, but not here, because a day is only 8 hours, because you go home and sleep and all that, so you want to divide that by 8. Okay. So 500 divided by 8, if you get a decimal, that's fine, 62.5 days. By the way, you're like, what about the 4 workers? It doesn't matter if there's 300 workers, okay? That's useless information, essentially, okay? And again, I'm using the rate with the weeks, because that's the answer, okay? 5 days, 1 week, I know the rate, the question mark's the actual. But you got to do a little finagling, a little division to get your days. So 1 times 62.5 divided by 5. It's just 62.5 divided by 5. I got 12.5, so it's going to take 12 and a half weeks. Okay, now we have another one of these. It's essentially the same concept, but I am going to explain what's going on for people that might want to go into electrician, stuff like that. The size of air conditioning equipment needed in a building depends on the number of windows and location of windows. The table lists a number and the amount of square feet of 3 different size windows. The heat gained through glass. Heat is measured. Heat you don't really see necessarily unless it's coming out of a toaster or something. But they have a temperature calculator, like, or whatever, a thermometer, and it's measured in British thermal units, BTU. That's what it means, British thermal units. That's how heat and air are measured. For each square foot of glass shown on the table, find the total heat gain for the building. So here's my rate, 20 BTU per hour per square foot. Okay, we don't really care about the H. But we use that for every square feet of window. Well, the first window they're talking about has 15 square feet, so I take 20 times 15, but that's just for one of those windows. This must be a huge house. Then we take it times 5 because there's 5 windows. 1,500. Then 55 times 15 times 12, that'd be 9,900, and then it goes the same as before. I'm going to just fill in the rest of this. These are accurate. I'm not just putting in things. I just want to speed the process. 0. If you have none of the windows, why, then you can forget about those units. 3,600, 15,300, 3,200, 11,000, 9,600, 20,400. Then you add them together, you get 111,350. Okay. That would be BTU, British Thermal Units. That's what they use to measure airflow. Okay, example 15. 2 contractors are mixing substances to construct drywall. One worker operates at a rate of 60 liters per minute for 45 minutes. A second worker operates at a rate of 50 liters per minute for 30 minutes. How many liters are made by both workers? Okay. So you got liters. We're not finding the rate, doesn't say each or per, so rate actual. So obviously we need liters. Now go find where it talks about liters in the problem. 60 liters per minute. So liters, and remember what that per means. 1 minute and 1 minute. I should have been putting the ones there as I read the problem, okay? Because that's your rate. 60 liters, 1 minute. Okay? And also we're going to actually need we're going to need 2 sets because there's 2 workers. We have 2 different rates, so I'm going to make 2 proportions. This guy here can do 50 liters in 1 minute. Okay, actual. Liters, minutes, liters, minutes. So we got to figure out the liters. Minutes, well, both of them are working for 30. So really it's just 60 times 30, which is 1,800. And this guy's 50 times 30. 68, it was just 1,500. Then add the 2 answers and you get 3,300. Okay, example 16. A chef is planning a menu for 400 guests. The main course is a 12-ounce steak. How many packages of 60-ounce steak will be needed for this meal? So we go packages. Rate actual. So we got to have packages. Now go find packages in the problem. Okay, packages of 60-ounce steaks. That means it's 1 package is 60 ounces. Makes sense. We got to figure out packages is what we don't know. Now ounces. Well, you see 12, but you don't just go with 12 because 12 is just for 1 person. You have 400 people, so you take 12 times 400, and that's 4,800. So 1 times 4,800 divided by 60, I think it's 200, we'll see. Is 80, okay, never mind, 80, I wasn't even close. 80 packages. Okay, example 17. A bookcase is produced in quantities of 700 by a manufacturer, so remember we need 700 of them. All pieces except the top and the back, okay, the top and the back are, like there's a back piece and a top piece. Those are made from 12-inch wide lumber. The top and the back are made from something else, don't worry. You're worried about the 2 sides and then the 3 shelves. Now this is important. 2 feet of stock are allowed for cutting and waste for each bookcase. When you're working on a project, a tiling project, you have to throw some waste away pretty much every time you cut a piece off. So some of what you need needs to be figured in for cut because it's worthless. You have to throw it away, but it's still part of what you bought. Okay. Find the total number of feet of 12-inch stock needed to manufacture 700 units. Remember, one apostrophe means it's in feet. So how many feet do you need for just one? Well, you need 2 5-feet pieces, which is 10, and you need 3 7-feet pieces, which is 21. Now add them together and that's 31 feet. But you need to add 2 on, okay? Because one shelf is 31 feet, but remember, every bookcase you make, you have that 2 feet that you have to throw out in the dumpster. So you'll need 2 feet along with the 31. So that's 33 feet, okay? So again, 5 times 2, 7 times 3, add them, but remember to add the waste on because you have to account that you need 33 feet, okay? 2 more than what the actual structure has. Okay, then that's for one, you need 700, so we just take 33 times 700. Gives me 23,100 feet. You can put the label or just the apostrophe. Okay, example 18 is a quick one. 200-foot long fence needs posts. The posts are evenly spaced with a post at the beginning and another at the end. If 21 posts are used, how far apart should the posts be? So you got a whole thing of don't draw this, just watch. The whole thing's 200, and you're going to be putting posts up. You don't need to draw 21. You're trying to figure out how far apart each post should be. Well, when you look at it, you're like, that's easy. I just take 200 divided by 21. Not 21, though, okay? Remember, there's always one more post than there are spaces. So if we have 21 posts, there's 20 spaces in between the posts, so we need to divide by 20. That's 10.